Our next talk is actually a recorded video. So after the video and during, if you could please ask questions and use the chat in the Whova app, the speaker would be able to answer your questions within the app. So the next talk will be by Alex Pavlushkin from Beta Software. And yeah, so we can go ahead and start the video.
Hello, thank you for organizing this amazing event. Today I'm going to talk about our experience of using large language models to generate FHIR output, and I'm going to share some insights we got and demonstrate how this approach can be used in a real medical application using different medical contexts. My name is Alex and I build medical applications on top of FHIR. And one of my main interests is how to make medical information systems more practitioner-friendly and how to reduce this burden of filling tons of medical documents. How improve this aspect? Using large language models looks pretty promising in solving this task, but at the same time it may be a bit overwhelming because we need to pick a right model rather some specific medical model, and we need to test how it can be used in different clinical contexts and test output. Yeah, use a lot of high quality data sets to train it properly. So as I said, these tasks include matching questions and answers. So if we have some raw text input, we need to address information from this input to a proper part of medical document. The second task is encode different conditions, procedures, medications, and other concepts to a list of allowed codable concepts in this questionnaire response. And finally, we need to combine different typical phrases, template phrases to describe some common. So let's see how it works. We have a practitioner and we need to choose a specific context. So we need to choose a questionnaire we want to fill out. The input can be provided as an audio or raw text. If it's an audio, we convert it to raw text finally and pass this data to LLM, as well as some prompt. That prompt includes instructions, includes questionnaire, related value sets, examples, and some other context medical data in FHIR format or just text. Then we run the model, and in case it requires some data, it can return the control to our application, and we create some additional form for practitioner to ask some specific questions that cannot be filled without additional information. If the model has enough data to generate a questionnaire response, we pass it to post-processing phase. What is that? At this stage, we add patient, practitioner, and counter, IDs and identifiers, and also append date for this questionnaire response resource. So make it a FHIR valid resource. Why we use post-processing? Because it's quite deterministic tasks and we don't want LLM to hallucinate. We rather do it in our code. Later they pass this questionnaire resource for validation, and in case of any validation errors, we return the list of these errors to LLM and ask to regenerate the output. Once it generates a valid output, we can show this questionnaire response to the practitioner, and the practitioner can adjust it manually or request or create new instructions to amend this document, and finally sign this document. Once we have signed questionnaire response, we run SDC extract function and generate some other resource update or create. And now let's see how this workflow can be used in different clinical contexts. I'm gonna show a couple of demos. The first demo is about screening of a pregnant woman. Okay, let's start the demo. So we need to choose a questionnaire. It will be second trimestral ultrasound pregnancy screening. This document comprises some numeric fields and has a choice question. Let's start the dictation. Gestational age 27 weeks. Fetal biparietal diameter 70. Abdominal circumference 130. Head circumference 150. Femur length 50. Humeral length 45. Estimated fetal weight 1000 grams. Fetal heart rate 150. Placental position anterior, right and left lateral ventricles 8 millimeters each. Even though we provided results in a slightly different order, the information should be sufficient to generate a draft of questionnaire response. Let's wait and see the results. Oh yeah, we got this document. Let's check if everything is okay. It looks like it's correct. It matches with what was provided. So in case we don't like, we can obviously edit in some way. Yeah, that's how it works. The second case demonstrates how we can use function calls to retrieve data from FHIR server in the runtime. It may be useful because even though the modern contexts are quite big, sometimes we just need to use specific query to get very predictable output. Let's choose patient summary, and here we have two fields: latest hemoglobin observation results and recommendations. I want to run this model without any additional prompt. Yeah, and we got the result and recommendation based on the logic for this low hemoglobin level. But what if we, for example, we can add new observation for this patient, and let's say it will be a norma. Yeah, we need to delete unnecessary fields, and it should be a bit later. Okay, we added an observation, and let's generate this document again. Perfect. As we can see, the latest observation result has changed, and recommendation also adjusted according to this changed result. Yeah, that's it. So we watched how this approach works in practice and what are advantages of this. First of all, it's simplicity. So it works well even with general purpose large language models like GPT-4 with no fine-tuning. Of course, using more specific models can bring better results and faster responses. However, that's nice that it works even with general purpose models. And transparency. So since the most of validation happens outside of the model, it's kind of solution of this black box problem. And of course, this approach has some drawbacks and limitations. First of all, we need to create these structured outputs. We need to create detailed questionnaires and write these validation rules to check the correctness of the output. And also, it looks like it works good for workloads where we can define more or less structured output, and may work not so good in a more vague scenarios with a big variety of options and paths. So, at this slide you can find the links to GitHub and contacts. We are looking for partners with whom we can apply this approach to real patient data. Thank you very much for your attention, and we have time for discussions.
Oh, yes. And so I don't think Alex is actually listening, but we can give him a round of applause. And